Welcome to Brain Vision.
Okay, this is question 5.88, losing cargo. We have a box resting on the bed of a truck, and the truck stops at a stop sign and then starts to move with an acceleration of 2.2 meters per second squared. And the box is 1.8 meters from the back of the truck, and we want to know how long until the box falls off the truck. So the first thing here, we know how the truck is accelerating, but we want to figure out how the box is accelerating. So to do that, we want to set up Newton's second law. So we have, if we think about this box sitting on the truck, it's going to be moving in the horizontal direction along the direction that the truck is moving. So there's only the frictional force that's going to be acting on it. And we know that this box is sliding, so we can say that this is going to be a kinetic friction force. And that's going to be equal to the acceleration. And I'm going to specify that this is now the acceleration of the box because this is going to be different from the acceleration of the car, which we had over here. So the frictional force is going to be mu k times the normal force. And the normal force here, since this box is just sitting vertically, sitting on a level bed, then this normal force is just going to be the mass times g. So when we look at this, we want to solve for this acceleration. So we can cancel out these terms m on both sides, and that's going to give us that the acceleration of the box is equal to mu k times g. So again, that's going to be different from this acceleration here. So now we want to know the time before the box falls off the truck. So we're going to need a kinematic equation here. Let's use our d equals v naught t plus 1/2 a t squared. Now the box is starting at rest, so v0 is 0. So we can just get rid of this term. And now this a here has to be the relative acceleration between the box and the truck. So the truck is, we're going to say that this a, this is the truck's acceleration, and we want the relative acceleration, so that's a minus a box here. That's what we're going to use for acceleration. And now t is what we're solving for. And we know that d is 1.8 meters. That's how long, that's the distance that we're trying to solve for. So we can just, if we just rearrange this equation, we can multiply both sides by 2 and then divide by this a minus a box. That's going to be equal to t squared. Remember, our a box here is just mu times g. So we have all of these constants. We have d, we have our a over here, mu k, g. So we plug these all in and then take the square root, and we should get t equals 2.221 seconds. Now, the second part of this question asks, how far does the truck travel in this time? So now we want to use the same equation, except now we're just looking at the truck. So we're not using a minus a box here. We're just using regular a, and we can now plug in our t, 2.221 seconds here. So we're going to just plug in a is 2.2, t is 2.221, and we should get that d is equal to 5.43 meters.